Hello, my BC kids. This is 2014, number 6 for the BC test. Let's take a look-see. So we're given the formula for the series for the function f of x. And they want the radius of convergence. They want r. So we're going to have to use a ratio test to find this. So we have a general term, a sub n is given. That's n plus 1. And then 2 to the n over n, x minus 1 to the n. All right, so that's a sub n. To do the ratio test, I need a sub n plus 1. Let me go ahead and put this here. N plus 2 to the n plus 1, n plus 1, x minus 1 to the n plus 1. And so in the ratio test, r is a sub n plus 1. So I'm going to put this one. And you divide by the reciprocal of a sub n. That's going to be n over all this stuff. And we're going to do some fancy schmancy simplifying. Oh no, I made a mistake. You guys probably saw that. That's a 2. So we cancel all of these. The top has 1 extra, so I'll be left with the 1 there. Oh no, Yoshida messed up badly. I forgot the plus 1 there. Cross out those. There's an extra 2 on top, so you have a 2. You cross these out. There's an extra 1 on top, and that's what we're going to get. So the ratio test, how do you do it? That's not r. I am just really royally messing up. That is a sub n plus 1 over a sub n. Now I take the absolute value of that and take the limit, and that will be my ratio for the ratio test. Absolute value of negative 2 x minus 1 n over n plus 1. Well, the x is a constant, n is the thing that's changing, so we can take the 2 and x minus 1 out in front and take the limit of the rest of n over n plus 1, and clearly this limit is 1, so we're left with this. And in the ratio test, it says if r is less than, if r is between negative 1 and 1, then the series converges. If it equals 1, it's inconclusive. So in summary, as long as the absolute value of that's less than 1, we're between negative 1 and 1. Now, that's not the radius of convergence. We need to get rid of the 2, divide everything by 2, and we're going to get this. So what is r? r is 1/2. That is part A. Part B, find the first 3 non-zero terms in general term for our series of f prime. About 1. So I'm going to find f. So I'm going to plug in 1 into this, and this will be 2, so that's going to be 1. It's going to be 2 over 1. So it's 2 x minus 1 to the 1. I don't need that 1. Then I'm going to plug in 2 everywhere. If I plug in 2 here, it's going to be a minus 2 squared is 4 over 2. You know what? I'll just do this. That way it'll be less confusion. Plus, then plug in 3, negative 1 to the 4th, 2 cubed over 3, x minus 1 cubed, plus, and then the general term. So they want the first 3 and then the general, which is all this. Let me simplify that now, because we have to take the derivative of this. 4 over 2 is just going to be 2. Negative 1 to the 4th is just 1. 8/3. And then we have all of this again. Yes. Okay, so we want the derivative. So that's one of the things. If we have a function and the series, the derivative of the function will equal the derivative of the series. That's one of the 5 things you can do to a series. So f prime of x, the derivative of this. So it's really, all of these technically are box, because it's a function and a function. So we do have to use the chain rule for all these, but the derivative of the inside is just 1, so it's not going to matter in the end. So the derivative of 2 times box will be 2, just 2. And the derivative of the box is 1. So here, second one, derivative of negative 2 box squared, it'll be negative 4 box to the first times the derivative of the box, which is just 1. And then here, 8/3 box cubed is 8/3 times 3, which is 8 box squared times the derivative of the box, but that's just 1. So those are the first 3 terms. Now I need the derivative of the general term. Here's where your brain freaks out a bit. So n plus 1 is a constant. N is a constant, all these. X is your variable. That's what changes. N, like for here, n was 1. Here, n is 2. Here, n is 3. So in each individual case, n is a constant. So n here is a constant. So if you have a constant, you just copy the constants down when you take a derivative. That doesn't change. Now we have x minus 1, or box to the n. What's the derivative? You move the n in front, subtract 1 from the n, and you multiply by the derivative of the box. So we move the n in front, and then we subtract 1. That's not a subtraction sign. Subtract 1, and we subtract 1 from the exponent, times the derivative of the box, which is 1, so we're done. And that's our general term. We could simplify. Those cancel. Anything else? I think that's it. So that's the answer to part B. Now we're going to do part C. So they're going to tell us in part C that we have a geometric series. This here is geometric. And you want to determine, okay, we want a couple things. First, let me read this. Taylor series found part B is geometric. Find the function f to which the series converges. So this is not as hard as you think. Your brain might freak out here. But you should know for a geometric series, the sum of a geometric, infinite geometric, is equal to the first term over 1 minus r, as long as the absolute value of r is less than 1. So that is the sum. So if you want to add up all these terms, it's going to equal this. That will be the function that equals this, plain and simply. So the first term, f of x, or f prime of x, the first term, a sub 1, is 2 over 1 minus r. R is your common ratio. So in other words, what did you multiply to go from here to here? What did you multiply to go from here to here? So your r is going to be negative 2. So to go from 2 to negative 4, you multiply by negative 2. And to get that, you must have multiplied by x minus 1. Now, to double check that, this times this should equal that. And I believe we are good to go. That's our r. Again, if you're told that you have a geometric, to find r, all you do is take any term and divide by the previous one. You take that and you divide by the previous. So you could have done this to find it if you didn't see it in your head. And you could have done like that. Or you could have divided this divided by that, and you'd get the same thing. So now we know our r, so it's going to be minus negative 2 x minus 1. That is our function for f prime. If you want to simplify it, I guess you could, but let me see. Oh, that's f prime. Sorry, Charlie. Yeah, find the function f prime. We did that. And use this function to determine the f. So after we find this, we have to find f. So let's do this. 2. In my brain, 1 minus the negative 2x is plus 2x. And then that's going to be a plus 2, so it's going to be minus 2. So that's going to be 2 over 2x minus 1. I hope. So the first part is done. We have found this. We found the function f prime of x. So in other words, this here is a series for this function. Now the question asks for f. Now it's saying the series converges on that. That shouldn't confuse you. The original series f converged on that interval. Therefore, using the derivative, it will have the same interval of convergence. So we're good to go on that. The last step, we need to solve for f. So we have to integrate both sides. So f of x will be the integral of 2 over 2x minus 1 dx. I need to do a u substitution. So u will be 2x minus 1, du will be 2 dx. Do we have a 2 dx? Lo and behold, there is that, 2 dx. And then, do we have a 2x minus 1? Of course we do, because we determined that's what u is. So, very wonderfully, we have integral on top du, on bottom u. It's ln absolute u plus c. So f of x equals ln, what is u? 2x plus 1 plus c. But we have to find c. The only way to find c is if they tell us a point in the original. Do we know a point in the original? Somewhere they told us f of 1 is c, and I don't, or 0, and I don't. Oh, I'm not sure where they're getting that from. F of 1 is 0. Let me reread this problem about x equals, oh, that makes sense. Look at the original equation. Wow, that would have probably messed me up on a test. If you look at this and you plug in 1, all the terms have x minus 1, and so it's going to be 0. So knowing that f of 1 equals 0, plug in 1 for all the x's, you're going to get 0 equals ln of 2 times 0 plus 1 plus c. So 0 equals ln of 1 plus c. But the ln of 1 is 0. So c equals 0. So our final answer, f of x equals ln 2x plus 1, done. That's it. Bye.